Welcome back. This video is about linear programming, is one fancy way to call it. Basically it's about, okay, I have this big long word problem. How do I write linear inequalities from it? Linear inequalities meaning there's no x squared, it's just a line. And inequalities meaning it's got like a greater than or a less than sign in it somewhere. It's pretty long for me to type up new ones, so this video is going to be a little bit different in that you're really going to have to pause the video and make sure that you understand the one explanation, because there's just one example in this one. If you want other examples, there is one on page 241 in your book, number 75, and then there's another one a couple pages later. So let's go ahead and get started on one of them. So go ahead and read the example yourself while I read it to you. A worker at a certain company can make 3 suit coats and 4 evening dresses in a day. The suit coats take 3 yards of wool and 2 yards of cotton to make. The evening dresses take 1 yard of wool and 4 yards of cotton. The company has a maximum of 10 yards of wool and 20 yards of cotton in stock for this day. Go ahead and create the table, find the inequalities, and use them to create the graph for this situation. So the reason why I like that this problem says to create the table is it's nice to try a couple numbers first. Now, all of these, there's going to be 2 things you're changing. The thing that you can change in this one is, well, you can change how many suit coats this worker makes and how many evening dresses this worker makes. That's the only thing you can change. You can't change how much wool or cotton each thing makes. You can't change what you have in stock. The variables are how many suit coats you make and how many evening dresses you make. Now you have to decide, which one do I want to be X and which one do I want to be Y? It doesn't matter, no difference. I'm going to have X be the suit coats and Y be the evening dresses. Alright, so let's guess one. Now, I mean, I've kind of looked at the problem before, so this might be a little bit easier for me, but it doesn't matter if you guess one that doesn't work. But I'm going to guess for X and Y. I'm going to guess, how about 2 for X and 3 for Y? So now what I want to know is, does that point work out? So I'm going to graph that point, but I might have to erase it later if it's wrong. All right, so 2, 3, does that point work? Should I include it in my graph or not? Well, there's a lot of things I have to consider. One is that first thing with a number in it. The worker can make 3 suit coats in a day. Am I okay there? Well, yeah, I am, because I'm only making 2. So what I'm looking at is, because this 2 is less than or equal to that 3, I'm okay. The next thing I need to look at is, okay, the next number that I have there is 4 evening dresses in a day. Am I okay with that? Yeah, I am, because the Y column, the 3, is less than or equal to 4. So, since all those are true so far, everything works out. Now, that's just the first sentence. What I have for the next part is a whole bunch of information about wool and cotton. And hopefully, you can pull out of that the fact that the 2 things that are restricting me is, well, I've got some wool, I've got some cotton. So let's just talk about the wool to start with. Do I have enough wool? You should think about that for a couple seconds. Ask yourself, do I have enough wool? And try to compute it out and say yes or no for yourself. All right, I think the answer is yes. Now I'm going to have to show my work to be sure, but I think we're okay. What I got when I just did it in my head is that we're using 9 yards of wool for this example. First of all, I'm making 2 suit coats. Because there's 3 yards of wool for each suit coat, and I'm making 2, that means I'm using 6. So 2 times 3 because I'm doing 2 suit coats and 3 yards of wool for each one. Now I'm also using some wool for the dresses. And since it's only 1 yard for each dress, that means I'm just doing 3. Because 1 yard for each dress, and I'm making 3 of them, so that's 3 times 1, that's a total of 3. And yeah, I did do it right in my head. That's a total of 9. 2 times 3, 6, and then add on the 3 times 1, which is 3. And that's okay because it's less than or equal to 10. Erase this dresses, that's too close there. All right. So I'm okay about the wool. The next thing I have to ask myself is, am I okay when it comes to cotton? That's another thing in the word problem that restricts me. It means I can't do whatever I want. I can't make 1,000 suit coats and 1,000 evening dresses. That would be nice, but it's not possible. All right, so do I have enough cotton? Again, think about that for about 10 seconds and say, okay, do I know what I need to compute there? Do I have enough cotton? All right, I think, again, it works out. Not that it has to, but when you're guessing and checking, but I think it does work out. And here's what I was doing in my head. Well, the suit coats take 2 yards of cotton each. So the total amount of cotton I'm going to use is 4. I made 2 suit coats. Each one took 2, so that's a total of 4, 2 times 2. Now, for the cotton for the dresses, I'm making 3 of them. Again, that's the Y. And so that'll take a total of 12 because I'm making 3 of them and each one takes 4. And then of course I have to add those together to get the total amount of cotton. Total amount of cotton, 2 times 2 is 4, 3 times 4 is 12, so 4 plus 12 is 16, and that's okay because I had 20. So there's another inequality that works out, it's true. It means that in my final answer, I want to include 2, 3. Like that place should be shaded. It should be dark. Now, there are probably a lot of other points. I don't want to guess and check them all because it would take a long time. So I want to write inequalities that match each one. Now, I've actually got them right here. But what you have to consider is, well, what if I change the x and the y? Like, what would I change? Like, let's say I would want to make 1 suit coat and 4 evening dresses. Would that work out? Well, for the first sentence, yeah, because what I'd do is I'd erase this 2 right here, because I'm guessing a different number. Oops, I want to do erase. And I put a 1 there, and that's okay. And then the same thing here for this evening dresses. Yeah, 4 is okay because 4 is less than or equal to 4. I mean, it's right equal, so that's okay. Now, do I have enough wool? Well, I'm making 1 suit coat. That's going to take 3 yards of wool. So I'm changing this number right here to be a 1. And for the wool for the dresses, each dress takes 1 yard of wool, so I'm using 4 total because I'm changing this 3 to a 4. And then again, for the cotton, well, do I have enough cotton? Well, I'm using 2 yards for each 1 suit coat. So 1 times 2 would be what I need. And then for the dresses, I need 4 for each one. And since I'm making 4, I do 4 times 4 to get a total of 16. So yeah, that still works out. So 1, 4 is another point that I want to be darkened in. Now hopefully you paid careful attention to which numbers I erased and changed here. Those are the variables. That's what I can change here. So instead of changing those numbers from 2 to 3 to 1 to 4, I can put an x and a y in those places. This 1 right here, it used to be a 2, that's the x. This 4 right here that used to be a 3, that's the y. And then I do that same thing in these other places right here. That those were both x's, like how many suit coats I was making. And then over here, I erased these 2 4s. I erased the 3's and put in a 4 rather. And I got that. Those are the inequalities. Now, let's graph them. The first one. y is less than or equal to 3. I'll make that one blue. Did I say y? I meant x. X is less than or equal to 3. That is a vertical line. There's no x-intercept. You can't type it into your calculator. What that means is it's a vertical line. That's the only kind like that. So I pretend it's an equal sign. Here's what it would be if it was an equal sign. Wasn't very straight, but that's the idea. And it should be shaded on the left side of it. But I will actually do that last. Then y is less than or equal to 4. Make that red. That can be typed in the calculator. It's a horizontal line. It looks like that. And everything that is below that works. So right now I have this rectangle that's close to 0, 0 that's bounded by the red and the blue line. Now I have two other inequalities to make. One that was about the cotton, which was the one with the 20 in it, and one that was with the wool that's right above it. All right, so I'm going to make that one black. There are two different ways to graph this. This one's a little bit harder. You could solve for y, so subtract x times 3 from both sides, and then actually that would be all you'd need to have to get y by itself. So that one's not too bad. You subtract x times 3 from both sides, then you could type it in your calculator and look at the table to help you out. Or you could just do the mx plus b thing where you know that b is the y-intercept and the number in front of x or with x is the slope. Or you can make a table, just like we've been doing, but make a table to graph that line. I'm going to solve for y. I think that's easier. So when I solve this black one for y, like I said, and again, I'm just pretending it's an equal sign even though I know it's not, I would get 10 minus x times 3. Now the x-intercept is what's by itself, the thing that is not right next to the x. That's 10. So the y-intercept for this one is 10. And then the next step, well, what's with the x? There's a negative sign and a 3. What that means is it goes down 3 over 1. So again, not the straightest of lines, but you get the idea. That's another boundary. So it cuts off a corner there that doesn't work from the wool. Like if I tried to do 3 comma 4, yeah, it would work for the first sentence, but it doesn't. You don't have enough wool. You must use more than 10 yards. Now I'm going to do the last one, which I'm going to do in green, which is the same color it's already in there. So again, I'll solve for y. I'll subtract x times 2 from both sides, but I won't be done after that. I'll have so I have 4 y's is equal to 20 minus 2x. Now to get y by itself, I just need to divide by 4. So I get y, oops, sorry about that, y equals 5 minus 2 over 4x. And now I'm going to graph that. That has a y-intercept of 5, and it goes down 2 over 4.
Amina Vortiz, please come to the main office. Amina Vortiz, please come to the main office.
I wonder, can you hear the announcements on the video? That'd be funny. They're kind of quiet here. Maybe you can hear it. All right, so anyway, y-intercept of 5, put that dot right there, and then it goes down 2 over 4. So this is what it looks like. And then I'm going to try to make this line look pretty good. So that's right there. So the points that work are the ones that are below all of them. So there's this, I don't know, is it a 5-sided shape in there, I think? The shaded region are all the points down here that are below all of them that work. And I could test a point like 0, 0, and every single one of these works, so I know it's going to be below all of them. That's a picture of the answer. Some problems ask you to find the best one, like the one that gives you the most amount of money. This is not one of those. It doesn't go that far, so you don't have to do that. All right, I know these are long problems, so if you want to come back to it later, you certainly can since it's a video, but I definitely suggest you try this out on your own right now. Pause the video, see how you do. All right, we're back. We're going to see how you did. I'm not going to explain it very much because this is already going to be a really long video, and I know you might just need to take some extra time or watch it twice or something. All right, so what I have for the second one is there's going to be, let's see, 1, 2, 3, 4, 5 inequalities. Assuming that the cougar is X and the gorilla is Y, we have a total of 6 in a week, so that limits me right there, which is X is less than or equal to 6. And the 4 gorillas each week, since I made that Y, looks like that. Now I have 3 other things. I'm limited by how many processors, sound chips, and memory sticks I have. So just for the processors, it'll be 2x plus 3y has to be less than or equal to 18. And that'll make sure that I don't use too many processors. For the sound chips, 5 times the number of cougars plus 6 times the number of gorillas has to be less than or equal to 42. Then for the, what do we got left? The memory sticks. I'm limited by 60. There's 4 in each cougar, and there are 12 in each gorilla, so I'm limited by that. When I graph each one of these, I need to solve for y. The first one, y-intercept of 6, goes down 2 over 3, so it'll look like that. The second one has a y-intercept of 7 and goes down 5 over 6. That one looks very similar, like that. And then the last one for the memory sticks, it has a y-intercept of 5 and goes down 1 over 3. So, has that sort of a shape to it. So there's a lot going on in there, but the points that work are in this region. I think that might be a 1, 2, I think it's just a 5-sided region. I don't think the 1 ever comes into play there. But those are the things that work. So how did you do? Can you do these kind of problems now? Write a bunch of inequalities, a system of inequalities that match one of these long word problems or not? If you can, great. If not, you can watch the video again, make sure you understand where I got each number, or come in, ask questions before or after school, ask a friend, whatever you need to do to be able to figure it out. Thanks for watching.